Okay, let's have the solution to example 56. Determine the member forces and reaction components of the space thrust shown if P is 15 kilonewtons and Q is 24 kilonewtons. So P 15 and Q 24 kilonewtons. So let's compute distance AD, which is equal to distance AC is PG and distance BF. So square root of 1.2 square along X, along Y 0.4 square, then along Z 0.3 square. So 1.3 meters. And these are the reaction components. Only one at E because this is the only member. We expect that the Z component and the Y component at the components of reactions are 0. So at A, there are only 3 unknowns here. So let's have the systematic equations of equilibrium. Summation forces X, leftward positive. So we begin with SAB, leftward positive, plus SAD times 1.2 over 1.3 plus SAC times 1.2 over 1.3 equals 0. Call that equation 1. Summation forces Y equals 0. Downward as positive. So we have S0 SAB plus SAD times 0.4 over 1.3 plus SAC times 0.4 over 1.3 plus 15 equals 0. So equals negative 15, equation 2. And summation forces along Z equals 0, forward positive. So again, AB has 0 Z component plus SAD times 0.3 over 1.3 minus SAC times 0.3 over 1.3 plus 24 equals 0 or equals negative 24, equation 3. So solving equations 1, 2, and 3 simultaneously, we have SAB equals 45 kilonewtons, SAD equals negative 76.375 kilonewtons, and SAC is equal to 27.625 kilonewtons. Then, considering the whole system, summation moment about FGZ equals 0. So by right thumb rule, that's the positive sense of moment to solve for X sub E. So X sub E times 0.4, everything will be out, equals 15 times 2.4. So XE times 0.4 equals 15 times 2.4. So X sub E is 90 kilonewtons in the negative direction. So that's the reaction, X component reaction at E. Then at E, summation forces X equals 0. Then let's call this SBE. So SBE rightward equals 90. So SBE is 90 kilonewtons tension. Then whole system summation moment about Fy equals 0 to solve for this reaction Xg. So by right thumb rule, Xg is positive. Then Xe is negative. 24 is negative. So Xg times 0.6 equals or minus 90 times 0.3 minus 24 times 2.4 equals 0. So take note, this is the axis. So X sub G is equal to 141 kilonewtons rightward. Then summation moment about YG equals 0 whole system, or GY or YG, to solve for XF. So by right thumb rule, XE is positive. Then XF negative, 24 negative. So 90 times 0.3 equals XF times 0.6 plus 24 times 2.4. So X sub F is negative 51, so that means XF should be leftward. Should be in that direction. So We proceed to whole system, then summation moment about fx equals 0. The main purpose of that in order to solve for yg. So by right thumb rule, positive moment should be in that sense. So 15 is positive, 24 is positive, yg is negative. So 15 times 0.3, because this is the plane of 15, so 0.3 its distance from fx, from this axis here, so is 0.3, plus 24 times 0.4. The x-axis is below, so 0.4. Then equals yg times 0.6. So yg is upward, 23.5 kilonewtons upward. Then summation moment about gx whole system to solve for yf. So by right thumb rule, yf is positive, 15 is negative, 24 is also positive. So yf times 0.6 plus 24 times 0.4 equals 15 times 0.3. So yf is negative 8.5. So that means yf is downward 8.5. So xg is, let's check the whole system. Xg is 141 rightward minus xf 51 leftward. So 141 minus 51 is 90. Then minus 90 is 0. So the whole system with respect to reactions along x is in equilibrium. Summation versus y, let's check. Yg 23.5 upward, yf 8.5 downward, 23.5 minus 8.5 is 15, minus 15 is 0. So it is also balanced along y. Along z, we do not know yet g sub z and g sub f. We will find them by the forces in members. Then let's check later on summation forces along z. So at g, summation forces y equals 0 to solve for the force in member bg. So SBG times 0.4 over 1.3. YG and SBG only will be considered in summation versus y because DG is horizontal. So SBG times 0.4 over 1.3 plus YG, which is 23.5, equals 0. So SBG is negative, or it is in compression, negative 76.375 kilonewtons. Then we can now have summation forces along x at g to solve for force in dg. So SDG plus xg, which is 141, plus SBG, which is negative 76.375 times 1.2 over 1.3, plus xg 141 equals 0. So SDG is negative 70.5 kilonewtons, so it is in compression. We didn't proceed. We then solve for g sub z, summation forces along z. So going in the negative direction as positive. So g sub z plus SBG, which is negative 76.375 times 0.3 over distance 1.3. Those are the only involved forces at g equals 0. So g sub z is correct. It is in the negative direction or backward direction, 17.625. Then we proceed to F, summation forces y equals 0 to solve for BF. So SBF times 0.4 over 1.3, those are the involved forces. Only two forces will be involved, YF and SBF. So SBF times 0.4 over 1.3 plus YF, which is negative 8.5, equals 0. So SBF is positive 27.625 kilonewtons. So we cannot set up summation forces x because we have two unknowns here, CF and DF. And we cannot also have summation forces along Z because we have two unknowns GF and DF. So instead, we proceed to join C, summation forces X to solve for CF. So we already solved, these are the involved forces. By the way, BC and CD are on the vertical plane, on parallel to the YZ plane. So there's no X component for BC and CD as well as BD if it is involved later. So summation forces X equals 0. SAC, which is 27.625 times 1.2 over 1.3 equals SCF. So SCF is positive 25.5 kilonewtons. So let's go back to joint F to solve for SDF. So again, let's proceed to joint F, summation forces X equals 0 to solve for SDF. So SDF times 1.2 divided by square root of 1.2 square plus 0 square plus 0.6 square. So it is 1.2 right, then 0.6 forward. So by the way, negative 51 plus SDF times 1.2 over square root of 1.2 square plus 0 along Y, then plus 0.6 along Z, 0.3, so 0.6 square. Then plus SBF, which is 27.625 times 1.2 plus SCF rather, which is 25.5 plus SBF, which is 27.625 times 1.2 over 1.3, then equals 0. So solving for SDF, SDF is 0. So SDF is 0. Now that SDF is 0, we can now perform summation forces along Z to solve for ZF. So forward positive, forward BF. So 27.625 SBF times 0.3 over 1.3, then equals backward. There's no other force involved because this is 0. This is parallel to x-axis. So only GF and BF. So GF can now be found. It is equal to 6.375 backward. So if you can remember, G sub G was 17.625. 17.625 in that direction plus 6.375 in that direction equals 24. So it is balanced along Z. So there's no problem about the external reactions. Everything is balanced. Now let's solve for the other missing forces or remaining forces. Let's go back to C, summation forces Y equals 0 to solve for SBC. So SBC is parallel to this. So 0.3 along Z, 0.4 along Y. So 5 or 3, 4, 5 is the slope. So summation versus Y equals 0. SBC times 4 over 5 plus SAC, which is 27.625, vertical component 0.4 of distance over distance. Then no more because these two members are horizontal, equals 0. So SBC is negative 10.625 kilonewtons. Then summation forces along Z to solve for SED. So SED plus 27.625 SAC times 0.3 over 1.3 plus SBC, which is negative 10.625 times 3 over 5 equals 0. So SED is 0 also. So because AC, BC, and CF are on the same plane, so automatic SED is 0. So that's the result also to verify that SED is 0. Then X, Y, and Z already. So let's proceed to D, summation forces. Let's check summation forces X because we already found AD, this is 0. So only two forces are involved because BD has no x component. It lies on the YZ plane or on the vertical plane. So we already found DG. So summation forces x0 SAD rather, which is negative 76.375 times x component of distance 1.2 over distance 1.3, then minus SDG, which is negative 70.5, and if you compute that, that's 0. So okay, it is in equilibrium at D along x. Then summation forces y to solve for SBD. So only SBD and SAD are involved. So SBD times 4 over 5 plus negative 76.7375 times 0.4 over 1.3 equals 0. So SBD is equal to 29.375 tension. Then let's check if it balances along Z. So let's check summation forces along Z. So going in the opposite or backward direction, positive. So summation forces Z equals 0, 29.375 times 3 over 5 plus negative 76.375 times 0.3 over 1.3, and the result is 0. So it is in equilibrium along Z also, joint D. So finally, let's check joint B. So let's put the values of the forces attached to joint B. These are the values. So summation forces X is 45 minus 90, then minus negative 76. So minus quantity negative 76.375 times 1.2 over 1.3 minus 27.625 times 1.2 over 1.3. And this BC and BD are not involved. They are on the vertical plane. So computing, it is equal to 0. So okay. Summation forces Y, downward positive. So negative 10.625 times 4 over 5 plus 29.375 times 4 over 5 plus negative 76.375 times 0.4 over 1.3 plus 27.625 times 0.4 over 1.3. So computing summation versus y is exactly 0, so it also balances. Then lastly, summation forces along z equals 0. So 29.375 times 3 over 5 plus negative 76.375 times 0.3 over 1.3. Then minus negative, minus because this is backward, minus quantity negative 10.625 times 3 over 5. Then minus 27.625 times 0.3 over 1.3. So computing that values, summation versus z equals 0. Because joint B is in equilibrium, the last joint, then we are sure that all our answers are correct. So this is it. This is the solution to this problem.